Okay, we're going to continue 14.2, and we left off with this, and we're going to use polar coordinates to solve this particular limit. So we set x to be r cosine theta, y to be r sine theta, and we have the limit then as r goes to 0 of r squared cosine squared times r cubed sine cubed. And on the bottom here, notice we can factor out an x squared here. So before I plug in, let me actually do the factorization so that this part is just r squared. And so what we're left with is r to the 5th cosine squared sine cubed divided by r to the 4th cosine squared theta. And so we're left here with the limit as r goes to 0 of r sine cubed theta. And so now, how do we proceed from here? Where r sine cubed is less than or equal to, or is greater than or equal to negative r and less than or equal to positive r, because sine cubed can be negative 1. However, as r goes to 0, if we take the limit as r goes to 0 on all sides, then this side goes to 0, and the other side goes to 0, hence what's in the middle must also go to 0, and hence the limit equals 0 for our problem. Okay, so this is another example of polar coordinate limits in several variables. We're going to now do one or two examples of the method of factoring. Algebraically, this is, it's not challenging, but it's not necessarily the easiest to identify as the method to use. That's what makes it challenging. So let's again just directly go into an example. Let's take x squared minus y squared divided by x squared plus xy minus 2y squared. And we're going to take the limit as xy goes to the point 1, 1. And you can note here that if you just plug in 1, 1, you'll get 0 divided by 0. So hence, that's an indeterminate. We don't know if then if the limit exists or not, because it's not a point of continuity. So we have to think of some other method. Now, well, it's clear that the numerator does factor into x minus y, x plus y. The question is, how do you factor this bottom part? So what I'm going to spend some time on here first before we finish up the problem, because once you've factored it, you cancel factors. It's just like the single variable process. But let's just look at this algebraically. X squared plus xy minus 2y squared. And we're going to think of it as a polynomial in x, as a polynomial in x. So the b term, if you will, this y is like your b, this is bx, and this entire thing here is your c term. And if you remember, or at least one method of factoring was making this little kind of diamond shape where the constant term, negative 2y squared, was here, and the b term, the middle term coefficient, in this case y, was here, and we needed two things that multiplied to get negative 2y squared, or the constant term, and added to get this term. And in this case, they're actually, well, they're variables themselves, but you can think of, for example, positive 2y and negative y. Those 2y times negative y gives you this negative 2y squared, and when you add these guys, you get y. So we can write x squared as x squared plus 2yx minus yx minus 2y squared. We can separate this and then factor two terms at a time. So we have x times x plus 2y, and then here we can factor out a minus y times x plus 2y, and then this becomes x minus y times x plus 2y, and now we have our factorization. Okay, so what we have then overall is the limit as xy goes to the point 1, 1 of x squared minus y squared, which became x minus y, x plus y, and the denominator became x minus y times x plus 2y. And now you can see that these x minus y's can cancel, and we have the limit of xy going to the point 1, 1 of x plus y over x plus 2y, and now we can just directly plug in to get 2 divided by 3. So this is the method of factoring, and it is useful, a useful method, and it does work out in some cases. So let me leave you here with a little exercise to try. So exercise. You're going to consider the following limit. So the limit xy goes to 1, 2, and this is going to be of x squared minus x plus xy minus y on the top divided by x cubed plus xy squared minus x squared minus y squared. Okay, so go ahead and try to factor the top and the bottom. It's sort of pre-made in a way where you factor two terms at a time. You might have to rearrange the terms a little bit, but essentially it's, you know, on the numerator and the denominator, factor two terms at a time. With possible permutations of ordering. Okay, we'll do one last video with this particular problem, and that'll be the end of 14.2.